Alright, hello everybody, welcome back to Trig Anometry. So, last two videos we were proving some identities. Like in the last video we were proving double and half angles. Before that we were proving sum and difference angles. So now we're gonna talk about sum to product and product to sum. That hopefully should conclude it, but who knows. So I found sum and product to sum to be a little confusing and weird at first, but when you find out the reasoning, you'll hopefully understand it. So, yeah, let's do this. So what we're gonna do is, we're trying to find an expression of cosine of A times cosine of B, sine of A times sine of B, sine of A times cosine of B, stuff like that. So we're gonna first start off with the cosine of A times the cosine of B. And we're gonna try to find that in the terms of cosine of A plus B and cosine of A minus B. Now you might notice that let me write this neater. So you might notice that the cosine of A plus B is equal to something, and the cosine of A minus B is equal to something. We learned this 2 videos ago, or a video ago, whatever. Yeah, 2 videos ago. This is equal to cosine of A sine of A minus cosine of B sine of B. This is equal to cosine of A sine of A plus cosine of B sine of B. Alright, so now we're trying to find cosine of A times cosine of B. We also want to find the sine of A and sine times the sine of B. And then finally we want to find the mix, so cosine of A times the sine of B. Why don't we want to find cosine of B times sine of A? Well, this is the same thing as this, but you just switch A and B, so that doesn't really do anything. Because commutative is existing. So yeah, so now let's try to find cosine of A, or let's try to find cosine of A, cosine of B. I don't really see it anywhere. So what do we do then? Maybe we can use sine, but sine doesn't really help. So what we're gonna do is we can add them. If we add them, so then if we add them, we're gonna get cosine of A plus B plus cosine of A minus B. The last two cancel, and we're just gonna be left with 2 times the cosine of. Did I write this wrong? Sorry, I wrote this wrong. Cosine of B minus or plus cosine of. What am I doing? Wait, what? Yeah, this. Okay, so then sine of A, sine of B, cosine of A, cosine of B, minus sine of A, sine of B. Okay, sorry about that. Hopefully you noticed that. If you did, congrats. If you didn't, congrats. Now let's move on. So if we add them, actually now I do see the cosine of A plus cosine of A times cosine of B and stuff. So, oh well, I guess if we add them, we're gonna cancel out the last two, and we're just gonna be left with 2 times the cosine of A, cosine of B. Now we divide by 2, and what we're left with is that cosine of A times the cosine of B is equal to the cosine of A plus B plus the cosine of A minus B over 2. Now, what else we can do is, if we subtract the cosine of A minus B from cosine of A plus B, we're going to get So we're gonna get cosine of a plus b minus cosine of a minus b. Okay, that's gonna get us to the first ones are gonna cancel, and we're gonna be left with 2 sine of a sine of b. Cool beans, cool beans, cool beans. So now what we can do is we can divide by 2, and we're left with the cosine, sorry, not cosine anymore, sine of a times the sine of b is equal to cosine of a plus b minus the cosine of a minus b over 2. So far so good in the hood. Now what we can do is we can we also have that the sine of a plus b is equal to sine of a cosine of b plus the sine of b cosine of a and the sine of a minus b is equal to the sine of a cosine of b minus sine of b cosine of a. Right, so cool beans, cool beans, cool beans, cool beans, and the cool beans, and the beans in the bags. So now what we're gonna do is we can use these. Because we're mixing sine and cosine, so this is gonna be better. So what we're gonna do is if we add them, and then yeah, we're just gonna add them, and we're gonna get Adam. My name's Adam, and we're gonna add them. My name's really not Adam. Okay, but yeah. So we add them. The last 2 cancel. We're gonna get we're gonna get the sine of a plus b plus the sine of a minus b is equal to 2 sine of a cosine of b. So that means that the sine of a cosine of b is equal to the sine of a plus b plus the sine of a minus b over 2. Surprise, surprise, surprise. Yay. Now, you might be thinking, hey, what if we subtracted them like a genius? Because that's what we did with the cosine. But if we subtract them, we're gonna get the same thing, or one of the same things, because we're just gonna get the same thing, but we're switching a and b, and it doesn't really do anything. So yeah, you just need to know this. If you switch a and b, then I think you can do that. But anyways, that's what we're gonna get. Yeah. So now, now what we're gonna do is we're gonna be using this thingy majiggy, and so yeah, sorry. So what we're gonna do is we're gonna be doing the sum. Yeah, this was product of sum. Now we're gonna do sum to product, and the difference to product. I guess last time it was what did we do last? We did product to sum, right? We did product to sum and product to difference, I guess, but I just like sum to product and product to sum, but I don't like difference to product and product to difference. But yeah, so now we're gonna do sum to product and difference to product. So now what we're gonna do is we're gonna go back to these ideas that we got over here. So now we want to find the cosine of. Okay, yeah, we're gonna start with cosine, right? What's the cosine of a plus the cosine of b equal to? Then we're gonna do the sine of a plus the sine of b. Then we're gonna do the cosine of a minus, wait, we're not going to do cosine sine. Instead, we're going to do cosine of A minus cosine of B, and sine of A minus sine of B. And the last one we could have done division, but we didn't, because we're rabid savages. So now what we're going to do is we're going to do these things. So now we want to do this first, right? Then we can lead it into the others. So, how can we do that? Well, yeah, so what we had was that, the cosine of A plus B plus the cosine of A minus B is equal to 2 times the cosine of A times the cosine of B. So you might notice that I think there's basically any number that can be represented as a sum of two numbers and the difference of those two numbers, right? Let's say we had, so like if you had 7 is equal to A plus B, and then 4 is equal to A minus B, then that means, oh, actually that's not a good example. Let's say we're going to do 3. So then that means that A is 5 because we add them, and then B is going to be 2, right? But let's say we want to do the 7 and 5. A plus B, they can reduce and do that, and then what we're going to get this time is we're going to get A is 6 and B is 1. So that was just an example. I'm just basically saying that we can substitute A plus B for X, right? Because we see the plus thing, plus cosine of Y. Now, I did this because these aren't uniquely connected or in any way. They're like, you can find some numbers that add to X and those two numbers subtract to Y. And then like X and Y are not really related. I mean, you can say that you could say that X is equal to Y plus 2B, but B can be anything. So now what we do is we say that's equal to, now we do this here thing, majig. Now we get 2 cosine of, what's A now? Well, A is X minus B, or X plus B, or Y plus B, right? But that doesn't really help, so we're gonna put it in the terms X plus Y over 2, because yeah, we wanted to eliminate the B, so we add them, and then we get, yeah, so that's what I did with the 7 and 3 thing. I added them to get 2A equals 10 divided by 2A equals 5. So now we can do the same thing here. Yeah, cosine of B, if we subtract them, then we're gonna divide by negative. Wait, yeah, if we subtract them, we're gonna get, 2B is equal to Y, so we divide by Y, so we get X minus Y over 2. So cool beans, that's basically it. Now we're gonna do the sine of X plus the sine of Y. So remember, sine of A plus B, oh wait, sorry, no. Cosine of A plus B minus cosine of A minus B is equal to 2 sine of A sine of B. Okay. So now what we can do is we can say that A plus B equals X, A minus B equals Y, so we get cosine of X minus cosine of Y. We can also say that in this case 180 or pi minus, and that'll make it negative, but I don't really feel like doing that way, so I'm going to use the usual way. Again, A is equal to X plus Y over 2. B is equal to X minus Y over 2. Alright, and that's it. Cool. So now we're gonna do 2 more. Yay. I just want to make sure that's right. Wait. What did I do wrong? I did something wrong. Oh wait, no. So yeah. So wait. Huh. Wait. That's equal to wait. Cosine of I'm confused. What did I do wrong here? Huh. Uh. I messed up somewhere. I think I messed up here. Oh, I'm so dumb. If I were doing this as a job, I'd be fired or something. Wait, okay, so sine of a times cosine of b is equal to sine of a plus b plus sine of a. Okay, that's right. Sine of a, sine of b is equal to 1 half cosine of. Oh my god, I'm so dumb. So now, here cosine of a plus b minus. That's gonna get us to negative. So we're really doing a minus b times, okay, a plus b. So now here we're gonna get, I'm a dumb bum. Sorry about that, guys. I know I keep making mistakes, but I don't think you know this, but I'm a human, and it seems kind of crazy. So now we do the same thing here. Yeah, okay, I was messing up. Alrighty, mighty. So now, what we're really gonna get is negative out here. Alright. So, oh god. Yeah, so that's cool beans. Remember that. I have a saying, but it's probably a little rude, so I'm not gonna say it. Okay, cosine of x plus cosine of y. Did I get that right? So let me. Yeah, I think that's right. So then, no, this thing, cosine of x minus cosine of y, that's equal to -2. -2 times the sine of x plus y over 2, sine of x minus y over 2. Cool beans. Now, what we're gonna do is we're gonna do sine and of instead. So now sine of x plus sine of y. What am I doing? Um. Yeah. So we add them, right? So sine of a plus b plus sine of a minus b. Oh, this bit is getting pretty long for just some simple proofs. Is equal to 2 sine of a cosine b. Nicey. I was thinking of thing that rhyme. Oh, spicy. Yeah. Spicy. Now I can move on. So now, what we can do is we can say that x equals a plus b, y equals a minus b. So now we're gonna get the sine of x plus sine of y equals 2 times the sine of x plus y over 2 times the cosine of x minus y over 2. Using this and this, we're gonna kind of use those later on with our so-called I think we already kind of used it when we were talking about complex numbers in algebra 2, when we were doing like the real part of z is equal to, and we like kind of like added the imaginaries and whatever. yeah, so like this thing is really important when we have a plus b and a minus b. You yeah, I think we had like the real part is like z plus the conjugate z over 2 or something like that. And then we had z minus the conjugate z over 2, and oh, good times, yeah, over 2y, I think so. So yeah, when we get to complex trigonometry, we're also going to use this again, where we add them and subtract them and all that. So now, cool beans, that's it. Now, last one. Sine of, this time we're going to do, um, wait, yeah, we don't need a whole thing this time, right? This time, I mean, I was saying earlier that I could do the pi minus and all that, but that part was ugly because we had pi minus theta equals, like, if you, like, because cosine of pi minus theta equals negative cosine of theta. But in this case, we know that sine of negative theta equals negative sine of theta, which is much easier, right, and much simpler to deal with. So, so that means that if you're trying to do sine of x minus sine of y, then we can say y is equal to negative z. So we're gonna have sine of, but yeah, actually we're just gonna write minus, we're actually just gonna use y again. Yeah, so actually we're just gonna use z, then we're gonna do something. So now sine of x plus sine of negative z, if you plug in y equals negative z, we're gonna get equals 2. I know my 2's look like z's, but I don't care, so shut up. Now times the sine of x minus z over 2 cosine of x plus z over 2. Now what we can say is that we can say that's equal to the sine of x minus the sine of y, or sorry, not y, z equals 2 times the sine. We can actually switch these because commutative property exists. And so that means that we're gonna have sine, or sorry, not sine first. We're gonna have actually we'll just write it like this because I like sine first. No offense, cosine, but you suck. So sine of, yeah, x minus z over 2. God, my handwriting is so sloppy if you didn't notice. I know, it's a modern talent, but you probably never heard of it because you're not cool. Alrighty, so now we can actually just say z equals, and we can, like, I know it seems unprofessional or whatever, but I like it in terms of y's rather than z's. I know it seems kind of confusing me switching out z's for y's, but it's nothing personal, okay? All we're doing is we're putting it in terms of x and y rather than x and z. Switching variables should not be new. It should be a concept or idea or something like that. So that's it. Thanks for watching, y'all, fam. And I'll see you guys in the next one. JK lol. I have 2 challenge problems for you guys. First off, actually I'll just give you one, cause I feel like. Find out, the sine of 13 degrees plus the sine of 40 degrees, or 47 degrees. I know ugly numbers, but suck it. So shuck it up. So now, suck it up and do these. It's a sine of 73 degrees. I know it's really nicey spicy, but yeah. Oh, spicy. Let's go, bro. Oh, that's a really low line. Why did I do that? Boom. I'm doing sound effects. sound like I'm a kid or anything. Kids are weird and lame. I'm just kidding. I'm not a kid at all. So now, do this. The source of this problem is the ARMA, or the American Regional Mathematical League, or something like that. But yeah, do this problem. Cool beans, cool beans. See you guys in the next one. You know what? JK lol again. Try it out. Now I'm gonna solve with you guys, because I hate doing a problem at the end of the video and then doing a whole solution video. I do a whole solution video because I don't like integrating a previous lesson. I don't like doing a problem in at the beginning of the next. I mean, God, I've done that so many times. I don't like doing a problem from a different video and solving it in another, because then you kind of have to hunt for it sometimes or whatever. Yeah, so let's do this, guys. So now, let's do this. That is equal to, I know it's spicy. So that, we can say that's equal to, if you use sum and product, I'm not going to look at it actually. What's the sine of A plus the sine of B? I kind of forgot it. So that's equal to, so that's equal to, you know what, I just forgot. 2 times this, okay, yeah, okay, I remember. Cool, I didn't really look at the full thing. So 2 times the sine of A plus B over 2 times the sine of A minus B over 2. Cool beans, cool beans. Plug that in. So sine of 13 plus the sine of 47. It's so nice how 13 plus 47 equals 60, because that's just such a coincidence. And 73 plus 107 equals 180. Oh, such a coincidence, you know? So that's equal to 2 times the sine. What's A plus B? Oh, wow, what a coincidence. It's 60. So sine of 30. Times the sine, 30 degrees, by the way. Sine of A minus B. 13 minus 47. I'd rather not. So what I'm gonna do is I'm gonna switch them. So I'm gonna write sine of 47 plus sine of 13 degrees, which is the same thing. So now what I'm gonna do, and so that's gonna be 47 minus 13. What's 47 minus 13, guys? That's 34. 34 over 2 is 17. And I thought this was getting nicer, bro. Apparently it's not. Wait, did I do this wrong again? Oh, cosine of x minus. Oh my god. Guys, I'm the best. No doubt about that. Sorry, cosine of 17, because, you know, that makes it better. Although I just noticed that there's a cosine of 17 at the bottom. Maybe something's gonna cancel. Yes, hopefully. Now that, so now we do that, plus, now this part is, the same thing we do again, and we're gonna get 2 times the sine of 30. Oh, no. Never mind. Oops. That was a mistake. The sine of 90 degrees. Yeah, we add them 180 over 2 is 90. So now 90 degrees times the cosine of A minus B. Again, I'm going to switch them and write 107 degrees and then first, and then 73 degrees. 107 minus 73. What is that, guys? That's 34. So now we're going to have 34 degrees. Wait, right? Oh, no, yeah, no, sorry. Then we divide by 2. Cosine of 17 degrees over the cosine of 17 degrees. What I notice is that that both of them have cosine of 17 degrees. Factor it out, and then we divide. Oh, thank goodness. Now I have nice things. Now 2 times the sine of 30 degrees plus the plus 2 times the sine of 90 degrees. Before you jump out and say that the first one's 1 plus, and then the second one is, before you jump out and say that the sine of 30 degrees is 1/2 and 1/2 times 2 is 1 and that the sine of 90 degrees is 1 and 1 times 2 is 2 and that's equal to 3. I already did it. So we did it, guys. 1 plus 2 is 3, and it's my honor to say that. But thanks for watching, and goodbye. And remember, spicy.